All right. Thank you very much for inviting me to your seminar. I'm Mark Nora, so I'm Science and Technical Manager at the River Restoration Centre in the UK. We're located in Cranfield University, which is slightly north of London. So today, what I'm going to talk about is the UK perspective on building action strategies for river restoration. So a short introduction of who we are. We were set up like some 25 years ago. So we've had like about 25 national conferences on river restoration. We started this year having international conferences as well on the science of river restoration, and that was in Liverpool, and we're going to have another one in 3 years' time. But our aim basically was to promote naturally functioning wildlife-rich river system valued by people. And the way we aim to achieve that was by promoting the reestablishment of natural processes, features and habitats and biodiversity within a river and floodplain systems. And we would do that by supporting and collating the knowledge and the evidence so that we could share that with the community of users. Remember that at the time, like some 25, 30 years ago, there wasn't a lot of knowledge about how we restore rivers. So one of the ways that we do that is by collating the information from science, figuring out what the best practice from existing projects, and then passing that on through producing guidance, which are available for free on our website. And also training courses. So we now have like a series of 12 training courses, which are running offline, but also online. We have like an online platform, and a lot of these training courses basically deal with issues which are central to the planning and the development of action strategies for river restoration. And they go from understanding how rivers work, like basic understanding of hydromorphology. Hydromorphology means basically the science of habitats. So it's looking at really the habitats within rivers. So from understanding the hydromorphology towards collating information in the field, from the air, and developing these restoration strategies. We're trying at the moment to also to put all these courses together into an MSc in River Restoration with Cranfield University, which will be available online as well for everyone. So how about developing action strategies or strategies? Well, there's more than one way of developing a strategy, basically. The current way, if you want, the one that's been used and what we're trying to get away from is opportunity-driven strategies. And this is an example that was it was a project by the Environment Agency in England, and what they did is to produce a map of opportunities for the natural flood management measures, such as removing embankments and reconnecting the rivers to the floodplain. The problem with these kind of initiatives is that they're really opportunity driven. So there is no clear sense of how the achievement of a measure would influence catchment processes and would help deliver objectives such as the Water Framework Directive objectives of good ecological status. So wherever there is an opportunity, then we can do something, but we do not know what the impact of our actions will have on the catchment and on the biological targets. So the kind of strategic framework we're trying to advocate is, for example, that framework which was used in this project on the Hampshire Avon, in which I participated and started in 2009, where the catchment was assessed, was surveyed, pressures and impacts were assessed at the catchment scale, and then a program of measure for dealing with these pressures and impacts was set up following on from the surveys. So I'm going to show you how we can basically develop these kind of strategic frameworks and move away from these opportunity-driven initiatives. So what we're looking to create, what we want and what we wanted to do within the River Restoration Center is to develop a process that will help us put together restoration plans that work at the catchment scale, not at the scale of an opportunity, a reach or something like that. Through the identification of pressures and impacts on catchments and river processes. The plan would help us identify a set of restoration options that would contribute to improving the catchment processing, and it would have to deliver some smart objectives, aim and objective, specific and measurable and realistic objectives. So that was the aim. So this is basically the river restoration planning and delivery process that we designed. It's got 6 phases on the left, from understanding your catchment, setting objective, then you've got the design of river restoration, delivery, monitoring, and review. From the point of view of the planning aspect, I will only consider the first 2, which is basically understanding your catchment and setting the objectives. So how is it done? So basically, first, before we start, we've got to adopt a way of looking at the catchment and analyzing what's going on within the catchment and the river environment. So we created a hydromorphological framework, which we teach at our introduction to hydromorphology courses, and basically it's basically a lens, a way of looking at a river. Because if you come from a fisheries background or a water quality background, you will look at the river in a specific way, and you will apply your basic understanding of how things work for fish or for water quality to what you see. What we wanted to do is to introduce a lens which will basically help people analyze what's going on from the point of view of habitats, because what we're trying to restore are habitats. So this is a hydromorphological framework which basically pictures the chain of causality, which basically will lead to the creation of habitats within the river system. So at the top of that chain of causality, we have the natural drivers of change. And this would be your energy, the climate, for example, but mainly it's energy, the amount of energy there is in the system, because the energy will drive the processes, the surface runoff, the erosion, the deposition within the channel. And these processes will create the forms, such as the riffles, in which, like the accumulation of gravel, in which salmon and trout spawn, and also the connectivity to the adjacent floodplain. And these will create the habitats that the species will utilize, and habitats and species are at the basics of the ecosystem. And obviously, beside that, we've got all the pressures which can have an impact on this chain of causality, and the pressures can have an impact at any point of this chain. It could have an impact at the level of energy, on the processes, for example, by protecting banks, or on the forms and functions by disconnecting the floodplain, by dredging the channel, and so on. So we need to look at these pressures and impact, and to understand what's going on at the catchment scale, and to build restoration plan. So how does that work in practice? I'm going to show you very quickly some examples. This is a kind of framework we teach. So we've got a series of 6 steps for catchment planning. First, we need to split the catchment into reaches. Reaches, I will describe what they are. Then we do a desktop assessment and the flyover survey. Then we go in the field, do some survey, we identify catchment pressures and impact, and then we identify river restoration measures and prioritize them before setting objectives. So in practice, reach delineation, extremely important. Why do we use reaches? Because it's much easier to analyze what's going on on a small scale. A ridge may be about 2 kilometers to 20 kilometers long. It has to be homogeneous in terms of the habitat, the hydromorphology. And what we want is one ridge to represent one set of conditions as observed, with impacts if you want, and one set of condition if it was natural, the reference condition. So to delineate reaches, we've got methodologies. This is a methodology we applied to 60,000 kilometers of river using a GIS in Bulgaria as part of a project with the World Bank. We used basically GIS to identify stream energy, which is your top driver, natural driver of change. Then we looked at stream size and land use, so that we could split the river network into a series of reaches with a minimum length of 2 kilometers for any reach. So the land use was really important because remember, a reach has got to be homogeneous in terms of the habitat, but also in terms of the pressures. So that is to facilitate the development of management actions and management plans. If we've only got one type of pressure, such as agricultural, then we can devise more easily some restoration action. Desktop assessment. This is a bit where we use online resources such as Google Map, LiDAR data, Street View, to have a first go at identifying pressures and impacts. So that's something that we teach as well, and there are a lot of resources online that you can use and that can be applied. But we also, as part of our project in Bulgaria, we designed for the Bulgarian Ministry of the Environment a flyover survey, and I was using Google Earth, and we had to do that because we could not go to Bulgaria during the COVID time. So the flyover survey that we taught to non-specialists was basically using Google Earth, but also Street View to identify modifications such as weirs, embankments, and start mapping them. And here you can see an example of realignment. And using this information, we were able to calculate a habitat modification index, which tell us about the amount of engineering and potential impact on the river that we put into 5 classes and produced a map for the entire country, showing the level of potential modification using this flyover survey. How can you use this first output? For example, for prioritizing survey. This is a real project on a catchment near to us. And we basically used a decision tree on the left, which may use of Water Framework Directive data about biological and chemical quality, as well as results from the flyover survey to start prioritizing streams for the production for survey work and the production of catchment management strategies and restoration strategies. So following this assessment over some 200 water bodies, we identified a series of water bodies where we would start doing the field survey work. The field survey is basically, we've got a series of methodologies, but within that framework, you can apply whatever methodology you're using as your national standards. In the UK, we're using the River Habitat Survey. We've designed a citizen version of the River Habitat Survey so that we can train volunteers to do the survey work. The other thing we advocate is the use of 360 cameras. You can see here a shot, a little video of these 360 photos, which we uploaded to Google Map, and which enable, especially when you're using volunteers for doing survey work, quality control, but also communication to whatever stakeholders and decision makers. You can literally get them to redo a survey virtually and have a look at the problems that you've identified on the ground. So the point of the field survey is basically to collect more detailed information and to map the pressures, identifying on the ground the impacts and evidence of impact, and start looking at restoration options and things that can be done on the ground. So once all the data have been gathered, then we need to look at pressures and impacts. So we first do that at the scale of reaches, because it's much easier to do an analysis at the reach level. And once you've identified pressures and impacts at reach scale, then we can start moving and figuring out the catchment issues and the catchment pressures and impacts. It's important, and that's what we teach in our course, to concentrate on impacts and not pressures. A lot of catchment management strategies have been based around managing pressures. We teach people to deal on impacts. Why? Because, for example, if we've got an issue at the catchment scale with fine sediment accumulation, which is causing trouble and problems for the biology, one impact may have several causes, several pressures. At the top of the catchment, it could be land use, which is causing fine sediment input into the system. Further down, we may have some realignment, which is basically increasing the amount of transport of fine sediment downstream. And finally, further downstream, you may have like some over widening of the channel, which is causing excessive fine sediment accumulation. So you may have more than one pressure, which will be impacting the catchment. So once we've identified these pressures, and we can basically summarize them in a table, and that's when we prioritize. So for each reach, we can have like all the pressures listed, and we can have like in the columns, the catchment impacts, all the major impacts have been identified at the catchment scales. And then we can have the measures that we can take to deal with the pressures and to alleviate the catchment impact. The important thing here, and there is a scoring, and you can see like the color of the cells, like from 0 to 2 with darker green. And what this shows is the potential effect, positive effect, that each measure will have on the catchment impacts. And that's the important thing. You don't deal with a pressure at a reach scale just for the sake of improving the reach. No, you deal and you score it according to the level of impact it will have on the catchment pressures. And this is how basically we built our catchment strategies for river restoration. So the important thing in summary is, first we take a catchment approach, and we've got like an overall catchment process with a more detailed planning process, which is based on sound hydromorphological principles. And by putting together and applying the strategy, we can basically, using, for example, the flyover survey, produce national and regional scale assessment, which we can use then for water body or catchment prioritization for work. We can also develop some specific catchment scale restoration action plans. And we can also identify at a reach scale the kind of pressures and impacts and measures that we can take. And all that based on sound hydromorphological principles. So this we've applied to a series of catchments with a series of organizations, and we've done that not only in the UK, but also abroad. I've put in there some useful links where you can learn more about all these applications, and on also some advertisement for our next conference, the 25th one, if you want to join us in the UK and see how it's worked in practice. Thank you.
Thank you, Mark. This was really inspirational. Maybe we should just stop the seminar here and tell everybody to go home and apply it. Well, we have time, a few minutes for questions. Let's hear with you first. Did you have any questions from Slido? Yeah, you have to have a microphone for those who are on the streaming.
Yes, thanks a lot. My name is Jo Halleraker, and I'm now the project leader for writing the Norwegian action plan for river and wetland restoration. So I obviously see that we can reuse some of your approaches already now. But my question is, could you maybe say something about what is the sort of key bottlenecks for why haven't you done more river restoration before? It's already addressed in the regional river basin management plans related to the Water Framework Directive, isn't it? So can you maybe reflect a little bit of what's really the new things now compared to what you maybe should have done according to reaching good potential or good status in your water bodies?
Right. Okay. Yeah. Thanks for your question. The bottleneck is always the same. It's money and resources. What's happened with the Water Framework Directive implementation in the United Kingdom is that there has been like massive cuts in budgets in the government organizations. And as a result, the way of managing and delivering the Water Framework Directive has been shifted slightly, and they created what they call catchment partnerships. And catchment partnerships is at the scale of a catchment. We would put together all the major stakeholders, such as the water utilities and local governments and so on. And this would basically try to figure out the pressures and impacts at the catchment scale, and then produce some kind of river restoration or catchment management plans, if you want. So all that was delegated to these organizations with a bit of money given basically to organize all that. But that's basically massively slowed down the implementation of the Water Framework Directive, and there hasn't been much funding at all from government to do river restoration in practice. So it's probably something you know a little bit. There's a lot of talking about doing these things, but when it comes to basically reaching down the pockets, then that's where we find the problems. And that's one of the reasons why at the River Restoration Center we've tried to develop all the tools that I showed so that they can be used by non-specialists, because the government's pushed for involving more and more volunteers, and we've got the Rivers Trust, for example, who use a lot of volunteers to do all this work. And in the same time, the government organization have reduced massively in size. When I left the Environment Agency I used to work for in 2007, there was 15,000 employees, and now you've got 10,000, and with the same amount of work, if not more.
Okay, thank you. Any questions here in the room? Yes? You have to present yourself also.
Hi, Mark. It's Hamish Meyer here from CBEC. We're working in Norway with
Is there sound on this microphone? Yes. Okay.
Yeah. I had a question about your fundamental hydromorphology control and energy. In systems, river systems in Norway and north of Europe, sediment and wood are very important. It's not just energy, it's interaction of the energy in the system with sediments and wood, and antecedent glacial conditions especially being really important. How does that get factored into the sort of process-based assessment that you undertake, the sedimentary and large wood factors?
Yes. So when we teach like the building of these these catchment plans, the assessment is done. A lot of the assessment are done at the ridge scale, and indeed, if you're going to look at catchment scale processes, you would also need to look at the whole issue of sediment transport and wood, where it comes from. Just like the sediment, where does the wood come from? Where does it travel? And how does it affect the hydromorphology? I have to say this is more like fluvial audit territory, which requires a lot of skills, and we that's not really the level at which we teach. We're trying to get people to understand catchment processes at the courses that we run, and we're trying to get them to factor that into the development of these management plans. But it's definitely much more of a challenge to start like getting people thinking as a geomorphologist, a proper geomorphologist like you are, and looking at the processes that are acting at the catchment scales in space and time. So if we're looking at like the glacial aspects as well, all that would have to be factored in. But it probably, like when it becomes that complicated, that's when you need to involve professional geomorphologists and geologists who can basically help sort out the more complex issues that people are not going to be able to resolve within this framework and the kind of level of teaching we give them.
Okay.
Thank you.
Thank you.